So in class, we've talked about radian measure around the unit circle. We've talked about sine, cosine, and tangent values on the unit circle. Now I want to show you when we apply those. In my class, I usually give my students 10 questions and about 5 minutes to answer it. So if they know the unit circle well enough, they should be able to tell me sine, cosine, tangent, cosecant, secant, and cotangent values of the common angles going around the unit circle. Now, these are 6 practice quizzes, a lot like the quizzes I give in my class. I'm going to provide in the description below some links to those quizzes or those practice quizzes so you can follow along with me. What I would do is download all 6, print them off, and try one at a time. I'll also link in there where I begin each one of these practice quizzes. So here is our first one right here. There are 10 questions. And I'm going to take you through them and show how I just think about it when I'm given one of these things, how we use everything I've taught you to come up with the actual values. So I kind of have in my head this unit circle. I can't show you what's inside my head, but I can show you what I'm thinking about. And this says to do the sine of pi over 3. So I already identified that pi over 3 is that angle right there. And I'm thinking about this triangle. I know that the sine is the y values on that triangle. So the y value on this triangle, as we discussed in another video, is the square root of 3 over 2. So I'm thinking, all right, I've got square root of 3 over 2. That's going to be my y value. And so that's my sine value, square root of 3 over 2. For the cosine of 7 pi over 6, I'm thinking that's 1 pi over 6 past 6 pi over 6. 6 pi over 6 is right here on the unit circle. 1 pi over 6 is right there. Same triangle I just dealt with, but now it's looking like this if you put it right in here into that section. So I want the cosine value, which is this side of the triangle, and because it's to the left of the y-axis, it's going to be a negative x value. Remember, cosine is our x values, and it's going to be negative root 3 over 2. For the sine of 4 pi over 3, I think that's 1 pi over 3 past 3 pi over 3, which is going to be down here. So I'm thinking that it's going to be this triangle like this, and I want the y value. And so the y value here is square root of 3 over 2, and it's going to be negative. Let me zoom out so you can see that triangle a little bit better. There we go. And oh, I got a backup triangle, a backup circle right there, just in case I need it. The cosine of 5 pi over 4 is going to be 1 pi over 4 just past 4 pi over 4. So we're looking at right here, and it's a different triangle. Remember, our something over 4 triangle we talk about, that is going to be this square root of 2, square root of 2, square root of 2 over 2, square root of 2 over 2, 1 triangle. And so 5 pi over 4 looks like this when we draw the triangles down here in quadrant 3. And it is going to be the cosine, so our cosine value here is negative. The x value is negative. It's going to be negative root 2 over 2. The sine of pi over 6, I know that pi over 6 is right here. The sine value is my y value, so I'm dealing with this triangle right here, and it's oriented just like this. It doesn't match up with that circle, but it's oriented just like that. The y value is positive 1/2. The sine of pi, I know that pi is right here. Sine is the y value, so it's going to be 0. The sine of 2 pi. 2 pi is going all the way around the circle. The y value is 0. The cosine of pi over 2. Pi over 2 is at the top of the circle, and the cosine is your x value. Once again, it's going to be 0. And then the cosine of 3 pi over 2. There's 1 pi over 2, 2 pi over 2, 3 pi over 2. Cosine is your x value. Once again, we're going to get 0 there. And then finally, the cosine of pi. Pi is halfway around the circle, and the cosine is my x value. It's going to be negative 1. So that takes me through the first practice quiz. Now, we will make these a little bit tougher as we go along. Notice we only had 2 trig ratios that we went through, but the first couple ones, I keep it to just sine and cosine, so we get used to working with that. Let's look at quiz practice number 2. Right there it is. Let's bring over our triangle. Now this is something, if I'm giving you 5 minutes to complete this, this is something that you could sketch out that circle real quickly. So you could use that if you wanted to. Some people, after they do it for so long, they start to just see the triangles in their head. And that's a good thing because it makes it go even better for you. So we want the sine of pi over 4. Pi over 4 is right here. And so that's our 45, 45, 90 triangle. That's what it looks like because it's in quadrant 1. The sine value is the y value. That is root 2 over 2. The cosine of 5 pi over 6. Think about it in your head. Where's 5 pi over 6? It is 1 pi over 6 short of 6 pi over 6. And so I'm going to go through and actually draw, let me just highlight the x-axis here on this and highlight the y-axis, because when I'm looking at it, I have difficulty seeing where exactly the x and y-axis are. So we're wanting to look at 5 pi over 6. It is 1 pi over 6 shy of a complete circle. So my cosine value is going to be negative. It's the x value. And it's going to be this triangle right here. And it's oriented like this. And this is like a shiny paper. So sorry that's reflecting back in the camera. And this is going to be a negative root 3 over 2. Negative because it's on the negative x part there on the x-axis. 5 pi over 3. I think, okay, that is just 1 pi over 3 shy of 6 pi over 3. So we're talking about right here. And my triangle is going to be oriented like that. And so I want the sine, which is the y value. So it's going to be negative root 3 over 2. The cosine of 3 pi over 4. Well, 3 pi over 4, here's 1 pi over 4, 2 pi over 4, and then 3 pi over 4. And we're talking about this blue triangle right here because it's a 45, 45, 90. It's oriented like that. And we're talking about the x value because we're saying cosine. So it's going to be negative root 2 over 2. The cosine of 11 pi over 6, we are 1 pi over 6 short of being at 12 pi over 6, which is 2 pi. So we're right here on the unit circle. Here's my triangle. It's going to be oriented like this. We want the cosine value, which is the x value. So it is going to be root 3 over 2. The cosine is 0. 0 is right here. And we want the x value, which is 1. The sine of 2 pi. 2 pi goes all the way around. It's coterminal with 0. The sine value there is the y value, which is 0. The sine of pi over 2 is up at the top of the circle, and its value there is 1. The cosine of 7 pi over 4. 7 pi over 4 is 1 pi over 4 shy of 2 pi. So it's going to be this triangle, and it's going to be oriented like this. The cosine value is your x value, which is root 2 over 2. The cosine of 4 pi over 3. 4 pi over 3 is 1 pi over 3 past 3 pi over 3, which is going to be right here. It's going to be this triangle, and it's going to be oriented like this. The cosine value is your x value, so I'm going to get negative 1/2 right there. All right, once again, I'm going through these quickly, but you can slow me down if you're watching me on YouTube, or you can just pause the video and try it yourself. But you should be able to do these in about 5 minutes. I know you're saying, but you have all these things that you're not giving us on the quiz, but I'm finishing it a lot faster than 5 minutes. So if you have to draw it out by hand, you can draw out a circle within about 30 seconds. You can even draw out these triangles if you want to, so you can practice along. Here is practice circle, the practice unit circle number 3 here. I want the sine of 3 pi over 4. 3 pi over 4 is right here. The sine value is positive root 2 over 2. The cosine of 7 pi over 6, that's 1 pi over 6 past it. It's going to be on the x-axis. It's going to be negative root 3 over 2. I'm dealing with this triangle oriented like that. The x value is negative root 3 over 2. The sine of pi over 3 is right here in quadrant 1. It's going to look like this. Sine value is going to be positive, and it's going to be positive root 3 over 2 because it's that long side of the triangle. The cosine of 5 pi over 4. 5 pi over 4 is right here. Because it's over 4, remember, we're dealing with the isosceles triangle. But the triangle is oriented like this. We are talking about the x value, which is negative root 2 over 2. The cosine of pi over 6. Pi over 6 is right here. We're dealing with this triangle. The cosine is the x value, which is root 3 over 2. The sine of pi over 2. Pi over 2 is at the top. Sine value is just 1 there. The cosine of 3 pi over 2. 3 pi over 2 is at the bottom. Cosine is your x value, so it's going to be 0. The sine of 5 pi over 6. 5 pi over 6 is just 1 pi over 6 short of 6 pi over 6, or pi. So the triangle looks like this. If I could put it right on there, if I could shrink the triangle and fit it in there, but I can't. It just stays like that. So our sine value here at 5 pi over 6 is the x value, not the x value, the y value, or 1/2. At pi, we're going to take the sine of that. The sine is the y value, so we're at 0. And the cosine is 0. Right here is 0 radians. The cosine is your x value, or you get 1 right there. So that takes us through some of those values for sine and cosine. On quiz practice number 4, I'm going to introduce some tangent values that you should know. So at this point, you should feel pretty comfortable, if you're in my class. I'm assuming you're not watching this video all at once unless you just want lots and lots of practice. But maybe as we go along, you're watching one video at a time every couple days. So if you've been watching a couple days at a time, you should have, after those first 3, have gotten very comfortable with sine and cosine on the unit circle, and you're ready to tackle tangent now. Now remember, with tangent, if you need to write this down in your quiz, you have 5 options. You've got undefined, you've got 0, you've got the root 3 over 3, you've got 1, and then root 3 by itself. And these right here can be plus or minus, depending on which quadrant you're in. So remember, tangent, if you think about it as slope, because sine over cosine equals tangent, on the unit circle, sine is your y value, cosine is your x value, so it's your rise over your run when you're thinking sine over cosine. So the slope of the line is my tangent value. So if you can identify where the angle is, you can figure out the slope of it. 3 pi over 2, that's what we're going to start with. 3 pi over 2 is at the bottom of the circle here. And the slope of a vertical line is undefined. So this first one here is undefined. Sine of 5 pi over 3. 5 pi over 3 is just 1 pi over 3 shy of 6 pi over 3. So it's going to be the y value right here, which is negative root 3 over 2. The cosine of 2 pi over 3. 2 pi over 3 is going to be right here, and the cosine is the x value, which is negative 1/2. The tangent is 7 pi over 4. 7 pi over 4 is at 45, 45, 90 right here. And think about the slope on that 45, 45, 90. If it's oriented like this, you go positive root 2 over 2, negative root 2 over 2. If you divide one by the other, you're going to get negative 1. The slope of that line coming through here is negative 1 all throughout. The cosine of 5 pi over 6, that is 1 pi over 6 shy of 6 pi over 6. Cosine value is going to be negative root 3 over 2. You're thinking, remember, about this triangle right here, and this side is root 3 over 2. The cosine of pi over 2, that's at the bottom, and the cosine of pi over 2 is going to be 0. It's your x value there. Sorry, not at the bottom, it's at the top. I'm going through this too fast, but it's still 0. Pi over 2 is at the top, the x value there is 0. The sine of 3 pi over 4, 3 pi over 4 is right here. This sine is your y value, which is going to be positive root 2 over 2. The cosine of pi over 3 is right here. Cosine is your x value, so it's going to be positive 1/2. The sine of 3 pi over 2, 3 pi over 2 is at the bottom, and the sine is going to be negative 1. And then the tangent of 4 pi over 3. Well, 4 pi over 3 is just 1 pi over 3 past 3 pi over 3, so it's going to be right here. I want the tangent of that, which is going to be the slope of this line. Now remember, here's my options. The steeper slope is going to be the bigger number. So these shallower slopes are root 3 over 3. The one in the middle is going to be 1. And then this is going to be positive root 3. So that goes there. Positive root 3, that's the steeper slope. All right, that takes us through practice number 4. We're going to move on to practice number 5, which has now some reciprocal ratios in it. So we've also got tangent still in there. Hopefully you're comfortable with tangent. And for the reciprocal ratios, we're just going to find the sine, cosine, or tangent, and then flip it will give us our reciprocal ratios. So let's look at those. So looking at this one, the first one is tangent of pi over 2. So the slope at pi over 2, which is undefined again. And then we've got the cosine of 4 pi over 3. 4 pi over 3 is just 1 pi over 3 past 3 pi over 3. So this is going to give me the cosine value of negative 1/2. The sine of pi over 3. Well, pi over 3 is right here. The sine is your y value. And so our y value here is going to be root 3 over 2. The cotangent of 7 pi over 4. So here's our first reciprocal ratio. What I'm going to do with that is figure out what the tangent is, and then I'm going to flip it. So at 7 pi over 4, I am right here. The slope of this line is -1. So that I can write it out like that, -1 over 1. That's the tangent. Now if I flip that, I get 1 over -1, which is still -1. So the cotangent there is the same as the tangent. The tangent of 11 pi over 6, right here is 11 pi over 6. It's 1 pi over 6 shy of 12 pi over 6, or 2 pi. The slope here is that shallow option, which is going to be -√3 over 3. Remember, it's a negative slope because it's going downhill left to right. The cosine of 3 pi over 2, 3 pi over 2 is at the top. Cosine value there is going to be 0 because it's our x value. The secant of 5 pi over 4. So remember that s pairs with c, so I'm going to figure out what the cosine of 5 pi over 4 is first, and then I'm going to flip it. So at 5 pi over 4, we are 1 pi over 4 past 4 pi over 4, which is going to be right here. My cosine value is going to be -√2 over 2. If I flip that, I get 2 over √2. And honestly, on my quizzes, I'm happy for the reciprocal ratios if you don't rationalize them. There's not really a need, but maybe you got a teacher that cares. So we can multiply this by √2 over √2. This gives me -2√2 over, let's see here, 2, which just equals -√2. Next, we've got the cosecant of 2 pi over 3. The cosecant, let's see here, 2 pi over 3 is going to be right here. This is 1 pi over 3. This is 2 pi over 3 right here. And I want the cosecant of that. So I need to figure out what is the sine of 2 pi over 3. Well, the sine here is √3 over 2. And then I'm going to flip that. And that gives me the cosecant. So the cosecant is going to equal 2 over √3. And once again, I'm happy for the reciprocal ratios if you leave it like that. But if that just bothers you, then rationalize it. So we get 2 √3 over 3. The sine of pi is right here. The y value there is 0. The sine of 5 pi over 3. So 5 pi over 3 is right here. And the sine value is going to be the y value, which is -√3 over 2. Okay? That takes us through the first 5. Let's do one more, and this is going to be practice number 6. So if you've made it this far, you should be very comfortable with the unit circle. Like I said, you should be doing these just a little bit at a time, not watching it all the way through. But if you want to watch it all the way through just to knock out 60 questions, then do it. All right, so for this one, we're going to start off with cosecant of 2 pi over 3. 2 pi over 3, this is 1 pi over 3. 2 pi over 3 is right there. And I'm going to know what the sine of that is. So the sine of 2 pi over 3 is equal to a positive √3 over 2. I'm going to flip that and then rationalize the denominator. And this gives me 2 roots of 3 over 3. For the secant, I'm going to figure out the cosine of 11 pi over 6 first. So 11 pi over 6 is right here, 1 pi over 6 shy of 2 pi. And so the cosine value there is √3 over 2. So when I flip that, I get the secant. Well, guess what? It's going to be the same thing because it's the same value I'm flipping as I got in number 1. The cotangent of pi over 3. Well, I need to figure out what's the tangent of pi over 3. Pi over 3 is right here, and this is going to be √3. That is the tangent of pi over 3. You can't see it because I went off the screen there. The tangent of pi over 3 equals √3. So if I make it a fraction and flip it, I'll get the cotangent. So flipping it, I get 1 over √3. Rationalizing the denominator, I'm going to get √3 over 3. And that's the cotangent value. The tangent of 7 pi over 4. Right here is 7 pi over 4. The slope of that line is -1. The sine of 5 pi over 6. 5 pi over 6 is right here. The y value right there on that triangle is 1/2. The cosine of pi. Pi is right here. The cosine is your x value. That's going to be -1. The secant of 2 pi. Right here is 2 pi. What's the cosine of 2 pi? Well, the cosine of 2 pi is 1. So if I flip that, I still get 1. Secant is also 1. The cosecant of pi over 2. Right here is pi over 2. And so what is the sine of pi over 2? Well, that equals 1. It's your y value. Once again, if you flip 1, you get 1 still. So that's your cosecant. The cosine of 3 pi over 2. Right here is 3 pi over 2. I want the cosine value. That's my x value. It's going to be 0. And then lastly, the cotangent of pi. Right here is pi. What's the slope of this line? Well, it's 0. So the tangent of pi equals 0. Flipping that, make it a fraction and flip it, I get the cotangent of pi equals 1 over 0. You can't do that. It's undefined. So this one right here is going to be undefined. Okay. So that takes us through 6 of these practice quizzes. If you're in my class, we're trying these out every day. We're doing a little bit of work on the unit circle each day. And then we're going to be taking these quizzes probably at least once a week, if not more. So I want you to keep coming back to this video, keep practicing. Let me know if you have any questions, and thank you for watching.